We're going to wrap up our look at different types of chemical reactions by looking at one more class of chemical reaction, and this one that I don't think is in this section in your book, but it's a very important class of chemical reaction to recognize because it comes up over and over and over again. And it's called a metathesis reaction, and I think about it as switching partners for fun and profit. Classifying reaction types, really important. It's something that can help us understand chemical reactivity in a variety of systems, even if we haven't seen the specific reaction before. So that's why we're spending a little bit of time talking about these different reaction classes or reaction types. And remember, RXN is a common abbreviation for the word reaction. So if you see RXN on slides or anywhere, you should be thinking of the word reaction. So what is a metathesis reaction? In a metathesis reaction, we have two ionic compounds that are exchanging partners. Now, they don't necessarily have to be absolutely ionic, but usually it's two ionic compounds exchanging partners. Because they're exchanging partners, these are also often called exchange reactions. I actually kind of prefer exchange reactions because it's more descriptive, but metathesis is out there pretty commonly. So what does a reaction like this look like? Well, here's one, and I've done a little bit of highlighting just to help us see that partner swap. So sodium sulfate, Na2SO4 aqueous, reacts with strontium nitrate to form strontium sulfate and sodium nitrate. So switching partners, I take the positive, the cation from this formula, and the anion from this formula, and I put those together, so sodium and nitrate, sodium nitrate. I take the cation from the second formula and the anion from the first formula, I put those together to get strontium sulfate. So I've switched partners and balanced this equation up as well. If we do some accounting, we've got two sodiums going in, two nitrates going in, so we need two sodium nitrates coming out. We can also look at something like HCl aqueous, so hydrochloric acid and sodium hydroxide aqueous can react to form, let's switch partners again. So H and OH, H plus and OH minus combine to form water. Water sometimes called hydrogen hydroxide, if you want to hide the identity of what you're talking about. And the other half of those partners, sodium and chloride, swap partners to get to sodium chloride aqueous. Now, one thing to be a little bit cautious of, we can always, you can pick any two ionic compounds and write out something that looks like a metathesis type of reaction. But there has to be some reason for the reaction to occur in order for the reaction to actually exist. So we see a couple of examples here. In this case, we've got strontium sulfate solid. So that is two aqueous solutions combining to form a solid. That is a precipitation reaction because the solid will precipitate out of the solution in this case. Another way, or another reason that metathesis reactions occur is when we form a molecule. So in this case, we've got two ionic substances that are coming together to now form a water molecule, a nice stable little water molecule. This specifically is a neutralization reaction. We'll probably come across a couple of other molecule formers as we move forward, but neutralization is probably the most common reaction there. What if we don't have any of these things happening? Well, again, we can write something that looks like a metathesis reaction. Potassium chloride, ionic compound. Magnesium nitrate, ionic compound. Let's swap partners and make magnesium chloride and potassium nitrate. Well, everything is still in aqueous solution. I haven't formed a precipitate. I haven't made a molecule. So even though I can write out this chemical equation, I can balance this chemical equation, there's no actual reaction happening when we put these together. So that's one of the reasons why classifying chemical reactions can be very helpful. If we know what a precipitation reaction looks like and a neutralization reaction looks like, we can predict whether some combination is going to form products or if it's just going to be some random mixture of all of these ions floating around in solution and not really reacting with one another. So, quick review of the types of chemical reactions that we've talked about. We started out with composition or combination reactions where we've got two reactants combining to form a single product. So that's how we're going to recognize that one. Two reactants, two or more reactants, and just a single product in a composition or combination reaction. We then looked at the opposite of that. We looked at a decomposition reaction where we've got one reactant that's breaking down to form two or more products. That's a decomposition reaction. We looked at combustion reactions, where we have a fuel reacting with O2 gas. Oh, I forgot to subscript that. To form oxygen-containing product or products. So look for O2 gas to clue us in that we've got a combustion reaction potentially taking place. We looked at redox reactions. We said redox, well, pretty much any of these can be redox reactions. So again, we can have more than one description, more than one category for a given reaction. And finally, we looked at metathesis or exchange reactions where we've got two ionic compounds, usually ionic compounds, exchanging partners to form a precipitate or a molecule in a metathesis type reaction. We're going to have a lot of opportunities to look at chemical reactions. In addition to just balancing them, always give them a look and see if you can classify them, because when you start classifying them, things start to line up and things start to make a little bit more sense and show a little bit more consistency than if we just look at every chemical reaction as its own complete, unique, individual item. Good luck on those, and I'll see you next time.